we're going to start with the neural network now. And for that, we have to start with the building block of neural network. And the building block of neural network is something called perceptron. Let's just take a look at how the structure of neural network look like. We have inputs, and when we say input, each one of these are going to be a feature of each one of your data points. So for example, if you have an image, each one of these can be a pixel of your image. Or for example, if you have shape, the color of the shape, what the shape is, for example, rectangle, triangle, or something, those are going to be the features. So each one of these inputs doesn't mean the actual data, but it means the features of each data, because data comes in one at a time. So for example, if you have a yellow star, the yellow star comes in, but then the shape of the star goes here, the color of the star goes here. So these are the features of input data. These are features of the input. So data comes one at a time. And then you might have hidden layer, or you might not have hidden layer. I can have as many hidden layer as I need. For here, I'm just doing the demonstration because I'm not going to go through the neural network today. I'm just going to talk about perceptrons. So that's going to be your hidden layer. And then you have your output. And if your neural network is fully, And if it is fully connected, then each one of these are going to be connected to all of the neurons that comes after it. So this is how it looks like. The output is going to be whatever you're trying to figure out. Like for example, if there is classification, for example, if you want to know a picture is a dog or a cat, or if you have a picture of a number and you want to know which number it is, then those are going to be your output. So for dog and a cat, you just have two output, dog or cat. For numbers, if you have 0 to 9, you have 10 outputs. This is that. And then now let's talk about perceptron. Perceptron is each individual neuron that we have here is a perceptron. And this shape doesn't really exist in real world. This is just how we're describing the math that is going on. The idea is taken from the actual biology of a human brain, but these things don't actually exist. It's just math. This is just for visualization. This is just for understanding it better. In simple word, perceptron comes up with a line that separates your data. Okay, so for example, I have few triangles up here, and then I have few circles down here. Okay. And I'm going to say I want to separate these two from each other. So I can come up with a line, this line. And this line is going to separate triangles from circles. Okay? So this line, perceptron can come up with this line. This is the perceptron. These are the inputs that are coming in. So I can say I0, I1, I2. So these are the inputs that are coming in, and I have to say how important each one of these inputs are. And each one of these inputs have different importance. Some of them are more important, some of them are less important. For example, if you want to buy a used car, you would probably want to make sure that it actually works rather than you choose the color. Each one of these inputs have different importance, and we are showing those with W, and we call it, 0W0, W1. So these are the weights. So they're not going to change the position. They're not going to take your line up or down, but they're going to change the slope of the line. It's the same as m that we have in line equation. And then you have another thing that you're adding to this, and that's called bias, B. And this is the same as y-intercept that we have in the equation of the line. And so we have all of this, all of these together will show you where your line is and what is the slope of your line. Weights decide the slope of the line. So if the line goes this way or this way, and then you have bias decide if you're going up or down on y. So it's the same as y-intercept again. It's not always going to be in 2 dimension. It might be, you might have like 100 features, so you're looking at 100 dimension. You cannot see 100 dimension. Okay, it's impossible to see 100 dimension. So the only way for us to solve that problem is mathematically. So this is our output. We're using something called activation function. I'm just gonna say AF. So there's something called activation function here that's gonna say if it's you're gonna say, okay, if you're below, I want you to show me 0. If you're above, I want you to show me 1. So whenever you're getting a 0, you know that you have a circle. Whenever you're getting a 1, you know that you have a triangle.